Hello everyone. Today we are discussing CodeChef Starters 94. So we'll be looking at the first 5 problems of the division 1 till range queries. So let's move on to the first problem, which is possible or not. So in this problem, we have given an array of size n and an integer b, and we have to find a subsequence, okay, of a such that bitwise and of all the elements in the subsequence is equals to b. Okay, so uh, we have array a, we have some elements 1 2 3 whatever, 5 6 4 whatever elements. Then we have been given an integer b, let's call it maybe 4, and then we have to find a subsequence of this array a yani only we have to select some few of these elements such that their bitwise end is 4. Okay, so let me ask you a very simple question. If there is a number 4, let's represent it in bits. Okay, 4. If I use number, okay, which has 4 as a subset, I mean like 101, which is 5, and 1117, you can see 4 is a subset of this. What by what I mean subset is their bitwise end will be equal to 4. Their bitwise end is equals to 4. Okay, that 4 is a subset of this. The bits set in 4 are also set in these numbers. Okay, and 4 does not have any bit that is not set in these numbers. Okay, that is what I mean by the subset here. So if we take all of these numbers and bitwise and them, we'll never get a number, okay, which has this bit as 0, because we are only taking the subset. And we'll also get the minimum possible end, because if for example, let's say, uh, 4 and 7 will be 4, but suppose 4 is not present in the array. We have number 5 6 and 7. What is 5 and 6? 4. 6 and 7? 6. 5 and 7? 5. So if we take AND of all these numbers, we'll get 4, which is the minimum possible AND we can ever get, which also has all the bits the 4 has set in it. Okay, so the approach is pretty simple. And from the array, we take AND of all the numbers which has bit 4 set in it. Very simple. Okay, initially I set all the bit. Very simple. Now let's say 4 has bit 100 or b bit in b. Okay, I'll take the numbers which have this bit set. Okay, let's say I got a number here, then some number like this, or maybe some number like 011, or then let's suppose we got 110, we get 6. Okay, and since we have taken all the numbers, there will never be an end which is less than 6. Okay, so if this is equals to 4, the end we get in the end. If this is equals to 4, then there exists an answer, otherwise there does not exist an answer. That would be my approach. Okay, so let's check my implementation. Okay, the implementation is very simple. I set all the bits, 31 bits, in the number num, and then I ANDed it with all the numbers which have the bit. I take bsk. I ANDed it with all the numbers which have k set in it. How do we check that? If the number and k is double equals to k, then it has k set in it. Okay. Now let's move on to the problem 2, which is the wall matrix. Okay, so we are given a string of length n, and task is to create a particular string using the vowel matrix. Okay, let's remove this. Okay. Mm-hmm. So we okay. Hmm. Each piece contains exactly k vowels. Okay, so we are given some strings. We are given a string consisting of some vowels. Let's say A, B, C, D, then E, I, F, G, H, maybe U, maybe A here, and O. Okay, so we are given such a string, and then we are given a number k. Okay, what do we have to do? We have to partition the string into substrings such that each piece contains exactly k vowels. Okay, let's call k equals to 1 here. Okay, so we need at least one vowel, so a should be there. B, C, D are optional. Okay, in this case, so I can partition here, 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 or here, not here, because we need e here. So first partition will belong in one of those four spaces. Okay, second will have to belong here, obviously, so one case here. The third partition, um, we already got one vowel f, not after, it can be after I, F, G and H. Okay, the four cases here. After U it is must, A it is must, and after O obviously we don't need a partition. So as you can see the approach, what is 4 here? The distance between the vowels, and 1 again distance between the vowels, 4 distance between the vowels. So the pattern here is we have to take initialize answer equals to 1 and multiply it with the distance between the vowels, because you can partition at any of the space between those numbers, because the number of vowels won't change in that particular gap. Okay, this is k for k equals to 1. If they were k equals to 2, we can't check distance after each and every vowel. We have to check distance after uh, vowels which are multiple of 2, like after A and E. We have to check distance after this, because we need two vowels. There's those k vowels. After we get those k vowels, we'll take the distance. Okay, I will wait till we get k vowels. Let's say something, we get k vowels here. Okay, then we have some consonants, and then a vowel starts. Okay, so this is the space which we have to multiply, because we can partition here, 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 here. Everything is same because number of vowels is k here. Okay, so let's check my implementation. Okay, so the implementation was not very tough. We take the string input, then we make a function to check if the character is a vowel. It's better to make function in checking every time, then iterating through the string. Okay, what I'm doing is I am mapping, okay, on how many characters I'm keeping the prefix sum of vowels. Okay, like explaining here, there is 1, 1, 1, 1, and 2, 3. Like how many ones are there? That is the place where I can partition when I want k equals to 1. Okay, understanding? So what I'm doing is this v is the prefix sum of vowels. Okay, and then this is mapping, hashing, you can say, whatever. The first case, edge case, if v modulo k is not equals to 0, the total number of vowels present is not a uh, multiple of k, then there will always be a portion left which is not a multiple of k, which doesn't have vowels in the multiple of k. So in this case we output 0. Okay, then after, okay, if it first percent k equals to 0, that is the main condition. Only we check only after the prefix sum of vowels is a multiple of k and it is not equals to 0. Okay, so if let's say we start the string, okay, we start the string from B, C and D and A, and k equals to 1, we can't partition in this, even though it is modulo k equals to 0, because there is no vowels here. Okay, we need k vowels, so we start from the first. And similarly, as we don't take the first portion, we don't take the last portion where it dot first is v. Similar, just do this and take modulo and the answer. Not typically too much too difficult. Okay, let's move on to the third problem, which is search for 104, a typical and standard DP problem. Okay, so in the problem, we are given a string which consists of three characters. Either there is 4, there is 0, or there is stars. Okay, so we can replace star with either 0 or 4. Okay, so we have to find subsequences of 404. We have to find number of subsequence 404 in all possible strings that can be made from this string. In all possible string that can be made from this string by replacing star with 0 or 4. This is the question. Okay, and then we have to take modulo, obviously. So as you know, these types of problem are typical DP problems. Okay, so how if there was no star, let's suppose, how do we handle this? Okay, we usually handle this by using how many fours have occurred at the moment, how many four zeros have occurred at the moment, how many 404 has occurred at the moment. When we iterate through the string, we get 4, we increment 1 here and increment number of 402 here, because for every 40 we will get a 404, you know. If we get a 0, we write 40 plus equals to number of 4s. Understanding? That is the general concept. But in this case, okay, what is the problem is, let's say we have a string called 4 star 4 star. Let's say if we replace till index 1 the string is always 4. When we go to index 2 we'll get two strings, 40 and 41. Okay, then 404, sorry, this is 44 444, and replacing this, now we get two more strings. Okay, which will be 4040 and 40. Okay, 4044 triple 40 and 4444. Now how do we handle the number of strings being doubled every time? Okay, so we keep three variables. Okay, number of fours, number of 4 and zeros we have got, and number of 404s. Okay, so every time we get a star, let's say the string is now 44400 and star, we'll get string as 4004 or 400. Till this index, the number of 4 we have gotten earlier and the number 40 we have gotten earlier and the number of answers we have gotten earlier will all be doubled. Okay, because the number of string is doubled with exactly with it being exactly same as the previous. So f into equals to 2, f z equals to 2, and number of answer is double equals to 2. Now we have to adjust cases where we either add 4 or we add 0. So when we add 0, we have to add the number of 4s. Very simple. And when we need number of answer, we add a z. And when we need number of 4s, now this is a little bit tricky because the number of strings are now st, and only on half of these you will add 4s. Okay, so number of string by 2, you will have to maintain this number of string in a variable, let's call this st, and multiply it by 2 every time. Okay, so there is one more important thing. So there is one more important thing We need to do the processing for fzf before fz, because we need fz before multiplying it by 2 till the previous index, not till this index. So we'll do this processing first, then this, and then this. That would be the natural order. And let's look at the implementation. uh, so iterating through the string, we have f0 and answer. Iterating through the string, f4 just incrementing answer plus equals to f0, and answer percent equals to mod f plus equals to number of string every time. Not too typical to handle. 0 very simple case, and then star case, everything calculating answer into 2 and plus f0 mod everything, then just outputting the answer. So in the problem special operation, we are given a matrix of n rows and m columns, and we have to select an index of the matrix. N rows and m columns. So we have to select an index of the matrix such that it's bitwise or with the elements that does not belong is this row and this column, that is this portion, this portion, this portion, and this portion is maximum. So basically if we check this value for all indices of the matrix, then we should get the maximum answer. So the real problem is the implementation. So what we can do is we have to store all the bits. Like in the problem the constraint is 30 bits, 2 to the power 30, the 30 bits, we have 30 bits. So for we have to store the number of bits 1 2 3 and so on till 30 in in each row and column and in total. Okay, so if the particular number contains the bit 1, the number of bits 1 here, 1 here, bits 1 in this region are not to be included, but the 0 bits are to be included. So if the index contains bit, contains, and not contains, so the formula for the number of bits in the region we need is total minus column minus rows, since we don't want to include both, plus the index itself. So we'll get the number of ones, the particular bit, the number of indices in this which the particular bit is set in the rest of the regions, and the implementation is pretty much the same. Taking input total row column, checking if the ith bit kth bit is present in aij, total of that bit plus plus in the column j, the kth bit plus plus, the row ith row, the kth bit plus plus, uh, for ijk again contains or not contains, simple. This is if it contains the kth bit, otherwise it don't contain. The contain variable stores the number of bits contained in the region we want. Okay, so the answer is if it contains number of contains into the value of the bit, obviously if it is 2 it's valued more, and otherwise n into m is total minus row n and column m and plus 1 of the index, and then taking maximum of for all ij, then outputting the answer. And the fifth problem was a bit tricky, but was technically a data structure based problem, uh, which used the PBDS. Okay, so the question we were given an array A, and the rank of the element in the array was defined. The rank was defined as number of greater elements, number of greater elements plus 1, not equal, just greater elements plus 1. So we used uh, okay, then we could select okay, we were given q queries in which we were given k and r, index and the rank. So what we needed to do, we had to make the rank of the element less than equals to r by removing few elements from the left of the index. Let's suppose this is the index. We can remove at most x elements here and x elements here, and we have to make rank less than equals to r. Okay, and at we have to find the smallest x, okay, for each such query. So what I did is pre-processed how many greater elements to the left and right of each element uh, using the PBDS. I made a pair of PBDS to act it as a like a multi-set rather than a simple set. Then just NQ, order of key, left, very basic stuff if you know. Then for then I did what I did is I checked the actual rank currently, which is number of greater element on the left plus number of greater element on the right. So I get the total number of greater elements and the rank we want. Then I subtracted it. If we do not require to any removal, then answer is 0. Otherwise, just a basic formula. Okay, if we can suppose we have to subtract a number k, and if k by 2 is present on both sides, we can simply remove k by 2. Or let's say only 1 is present on one side, then other side we'll have to remove k minus 1. Simple as that. So I just check minimum if half is possible, otherwise minimum. That is the solution, which is maximum required minus x and CL of required by 2.0. That's it for today. The solutions will be posted on Discord, which will be provided, and the link will be provided in the descriptions. So that's it for today. Peace out.